Tomorrow, you guys are going to take your algebra practice STAAR test. So today, we're going to go through everything that you need to know to be successful on tomorrow's test. The reason why we have to give these practice STAAR tests is because the state of Texas has not changed any laws about having to pass STAAR to graduate. So in high school, STAAR tests are called EOCs, and it is still a state law that students have to pass their EOCs on campus to be able to graduate. So if you don't pass your STAAR test, your algebra EOC this year, then you'd have to take it again, and then again, and then again. And if you don't pass it, then you can't graduate. So we want to make sure that you guys are as prepared as possible to be successful on your real EOC, which is in approximately a month and a half. So tomorrow's practice test will help us know exactly what you do and do not know, so that way you guys can be successful on the real STAAR test in May. So make sure that tomorrow, if you have a district Chromebook, that you bring that Chromebook with you to school. Make sure that it's charged, so that way you can use Desmos to help you on this test. You can also use Desmos on your real STAAR test, as long as you bring your charged Chromebook. If you don't have a Chromebook, we will provide you with one. But if you have been given a Chromebook, make sure you bring that with you and you have it fully charged. So we're going to go ahead and begin our review to make sure that you're successful in tomorrow's test. When we go through this review, write it down as we write everything down. And as we're typing in Desmos, make sure that you're also practicing as well. So the first concept that we have is called solving equations. So if we're solving for x, the first thing we need to do is make sure that this letter is an x. So the way that Desmos is programmed is it only works if these are x's. So I'm going to go through, and instead of writing n, I'm going to write the letter x. So what I have here is this left side. I am now ready to type into Desmos. The left side says -2, open parentheses, x plus 6. There it is. -2, open parentheses, x plus 6, minus 4, open parentheses, 2x plus 5. Okay, there's the left side. So now I'm going to take the right side and plug it into Desmos. 10, open parentheses, x minus 5, plus 8. Okay, so now if you have a touch screen, you can move your screen. If you don't have a touch screen, just use your mouse to move it over and touch where these two lines cross. So I want to know where these are equivalent. Equal means that they touch the red and the blue. And we're solving for x, so my answer is the x number of this ordered pair. So the correct answer is that these two lines are equivalent when the x is 0.5. So that's the correct answer for this first one here. Very easy. The next thing we learned is a lot of vocabulary that's used with linear functions. The first vocab word that we had is the word functions. Functions mean that the x's don't repeat. So if you ever see the phrase y as a function of x, if you ever see the phrase is it a function, does it not represent a function, what we have to do is check our x's. So in this example here, we have a -5, a 2, a -4, and a -5. What I notice is that -5 is with 3, and then -5 comes back with a 1. That is not good. So this is not a function. It is not a function because we had an x that repeats. The next word you learned is the word domain. Domain is always, 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 always the x. To write the domain, we put an x and we smush it between two sides. The x is the left to the right. The furthest x number is the number -4. The furthest right x number is the number +5. The left is an open circle and the right is a closed circle. So because the right side is a closed circle, that means I need to make sure that I close my symbol. So domain is x, which is the left side to the right side. Range is y, which is the bottom y value to the top y value. So I put a y and I smush it between two signs. My lowest y value graphed on this graph is the number -2. So my lowest y value is right here. That's a -2. My highest y value is right here. That y value is the number +1. The bottom one is a closed circle. So I'm going to close this symbol. The top is an open circle. So I'm going to leave this symbol open. And that's how you find range. Domain is x, range is y. Domain is left to right, range is bottom to top. The next set of vocabulary we have are called key attributes. So what this means, I need x-intercept or 0. It means the same thing. The x-intercept or the 0 is where your line crosses the x-axis. So in this graph, my x-intercept or my 0 is the number +3. I can write that as an ordered pair. It sits in the x spot, which is 3, 0. Next, I have a y-intercept. That's where my line crosses my y-axis. This one touches the y-axis at the number -2. So that's my y-intercept. I can write that as an ordered pair, where the number goes in the y spot of the ordered pair. Y-intercept, very easy. So now we're going to move into some Desmos. That's going to make your life really easy tomorrow. So what you need to know is if you ever see the phrase y equals or f of x equals, we're always going to plug it into Desmos. So in this first example, h of x equals x squared minus 3x minus 9. I'm going to plug that into Desmos. X squared minus 3x minus 9. Okay, you can click the little home button on Desmos on that right corner right there, and that takes it back to like the regular middle view. I'm going to zoom out a little bit. So what I notice about my original graph is that it touches the x-axis at the origin, that's 0, 0, but it also touches it at 6, 0. So if I look at this graph, it does not touch at the origin, and it does not touch at 6, 0. So therefore, the correct answer is not F. So now I'm going to try G. X squared plus 3x minus 9. H parentheses x equals x squared plus 3x minus 9. Okay, this one, nope, does not touch at the origin, does not touch at +6. So this graph is not the same as this graph. So the answer is not G. Letter H, x squared minus 6x. If I look at this graph, yep, and you can also put h of x in the front. It's the same thing. H parentheses x, it'll graph it the same. Equals. Like, now it looks exactly like letter H. And this h of x equals x squared minus 6x. Does this one touch at 0, 0? Yep. Does it touch at 6, 0? Yep. So therefore, this one matches 0, 0 and 6, 0. So the correct answer is H. So if you ever see y equals or f of x equals or h of x equals in a graph, you just type it into Desmos and you carefully look to see which one matches. So we're going to do that same thing every time you hear the phrase equivalent. So equivalent means what is the same. So you guys did this by hand where we double distribute or FOILed, but you can also use Desmos to make sure that you get it correct. So anytime you see the phrase equivalent, you just take this and you type it into Desmos. 4x plus 2 and 2x minus 6. Parentheses, 4x plus 2, parentheses, 2x minus 6. Okay, so here's my graph. My original one is red, so I'm going to write the word red. and I plugged it into Desmos. Anytime you see the word equivalent, you can always just plug it into Desmos. So now I'm going to plug option A and see if it's equivalent, see if it's the same. 8x squared minus 12. Is this blue graph exactly the same as this red graph? No. So therefore the answer is not A. 8x squared minus 20x minus 12. So in this one, that red graph, the red graph and the blue graph are exactly the same. I don't know what just happened. This red graph and the blue graph are exactly the same. So therefore, the correct answer for this one here, so weird, I don't know what just happened. Correct answer is B. Okay, so that is how you can check to see if they are equivalent. In this next one here, I see a y equals, so I'm going to go to Desmos. Let's zoom in so you can see it better. So I'm going to use Desmos to see this one here. So I'm going to press y equals negative 2x plus 0.5. Okay, so this gives me a graph, but I don't want a graph. I want a table. So in a table, what I'm going to do is I'm going to press this little circle button right here, and I'm going to click table. So I want to know if this table matches my table. When x is negative 1, is the y 4? Let's find out. When x is negative 1, nope, the y is not 4. So the correct answer is not A. Now let's check the second table. When x is negative 1, is the y 2.5? Yep. 2x. Oh, it's negative 2x. Sorry, guys. I typed it in wrong. There we go. When x is negative 1, yes, the y is 2.5. So therefore, this is correct. I had a typo. This is supposed to be a 0.5. On this table, when x is 0, is it 0.5? Yes, it sure is. On this table, when x is 4, is the y negative 7.5? I don't know. Let's find out. When x is 4, yep, it is in fact negative 7.5. So this one's also correct. So the correct answer is B. Next one, same idea. What is the equation in slope-intercept form of the line that passes through this? So I see a y equals. When I see a y equals, I'm going to go to Desmos. I'm going to type it in. Y equals 0.25 x plus 30. I need the table, so I click the little circle. I click the table. What I need to see is that when x is negative 4, is the y 2? I don't see it yet, so I'm going to type at the bottom. When x is negative 4, yep, that y value is 2. So far, this one works. But let's check this. From the table, when x is 12, is the y 6? Yep, when x is 12, the y is 6. So therefore, this answer choice, this y equals, has both of these ordered pairs on its table, so the correct answer is F. Okay, last one of these. Anytime I see a y equals or an f of x equals, I just type it in. F of x equals 6, open parentheses, 1 minus x. Okay, so that's the original one it asks for. Then it asks for f parentheses negative 8. So what that means is that when x is negative 8, the answer is right here. The answer is 54. If you ever see f of x, just type it in exactly like you see it. And then it was asking when f of negative 8, and your correct answer is 54. You type them both into Desmos, and you see what number it gives you right there. Okay, so in this one here, we have slope and rate of change. So what that means, slope and rate of change. So slope or rate of change means the same thing. On a formula sheet, you would have a formula chart that says y2 minus y1 over x2 minus x1. That's how you get the slope or the rate of change from 2 points. So I'm first going to show you how to do this by hand, and then I'll show you how to do it in Desmos. So in this one here, we would start by labeling xy, xy, 1, 1, 2, 2. Then I'm going to plug it in. So I'm going to start with my y2, which is negative 10, minus y1, which is 6, all over x2, which is 4, minus x1, which is 2. Negative 10 minus 6 is negative 16. 4 minus 2 is 2. Negative 16 divided by 2 is the number negative 8. So that's how you do it by hand. So now I'm going to show you how to do this using Desmos. Okay, so what I'm going to do is I'm going to click the plus sign, and then I'm going to click table. So in Desmos, the plus sign is the top left, and then I'm going to click table. So I'm going to type in this table. 2 goes with 6, 4 goes with negative 10. Okay, then to figure out the slope, we're using the formula y equals mx plus b. You've heard that a billion times before. But instead, we have to make sure that we're putting y1, it's just the way it's programmed, this little squiggly line, m x1 plus b. And then you see the m is the slope, so the answer is negative 8. Okay, when you're ready, go ahead and try number 2. You can use the slope formula, but be very careful with your decimals. If you're using the slope formula, your y2 minus y1 over x2 minus x1. If that confuses you, you're going to click the plus sign on the top left corner of Desmos. Then you click table. Then you type in these numbers. 1 goes with negative 5, negative 3 goes with negative 8. And your answer is y1, squiggly line, m, x1 plus b. Okay, so you can try number 2. When you're ready, let's move to the next one. What is the rate of change from the table? So again, I'm going to go to Desmos. I'm going to click the plus sign, table, and I'm going to fill it in. Negative 2 goes with 12. Negative 1 goes with 25. Zero goes with 38. Then the equation of the line is y equals mx plus b. So we write that as y1, squiggly line, m, x1 plus b. Then my answer is the m for the rate of change or the slope. So the m equals 13. Okay, you can try the same thing with the next one. When you're filling this out, if you're using Desmos, negative 10 goes with negative 8, negative 5 goes with negative 38, 0 goes with negative 68, and 5 goes with negative 98. So you click the plus sign, you click the table, you type it in, and then y1, squiggly, m, x1 plus b. Okay, let's move to the next one of this. Rate of change, same thing. Rate of change from a graph is just the slope. So in order to find slope, I'm going to pull off two perfect points. Here's a perfect point. That's the ordered pair, 4, 40. Here's another perfect point. That's the ordered pair, 8, 80. You can solve this by hand using the slope formula, or you can use Desmos and just type those in. Plus sign, table. 4 goes with 40. 8 goes with 80. The equation of a line is y, 1, squiggly line, m, x1 plus b. The answer is the m, so m equals 10. Okay, one more for this side. Now we are going to simplify radicals. Simplifying radicals means we type this into the calculator exactly as we see it. So I'm going to write 4 square root of 147. To do that, I type a 4, the square root sign, and 147. So that number is equal to the number 48.49. So now I need to see which of these answers is that same decimal. So I start with A, 196 square root of 3. And that's the number 339.48. That number is not the same as the original number that we're looking for, so the answer is not A. So we're going to try B, 12 square root of 7. This answer is 31.74. That decimal is also not the same as the original one, so it's not B. Next, 3 square root of 7. That number is also not the same, 7.9, so it's not C. So we need for it to match this one here. So let's try D, 28 square root of 3. So easy, 48.49. That one does, in fact, match the original. So the correct answer is. All right, so we now move into the next piece, which is called linear inequalities. So these are not too difficult. What we need to do first is look at our sign. In this sign, there's no line underneath it. So that means that when we graphed this line, we started at 0, 0. It went up 5 and over 1. There's no number in the back, so that's why we started at 0. And then the slope was up 5 and over 1. So in this symbol, there's no line underneath that inequality symbol. So if there's no line, it means we can't draw a line. We have to draw dashes. So then there's two things that you guys have to remember, the less than and the greater than sign. If you drop a straight line on this one, it makes a D for the word down. If you dropped a straight line on this one, it makes the letter P for the word up. So in this first example, this symbol right here is the less than sign, which you could drop a line, and that would make a D for down. So you put your pencil on any point, and you drop it straight down. And then you color, 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 color. And that is the graph of this first one here. In the next example, this one does have a line. So to make these ordered pairs, they started at -4. That was my y-intercept. Then they went up 1 to the right 2, up 1, right 2, up 1, right 2. Okay, so this symbol does have a line under it. So what that means is we need to connect our dots with a straight line because there's a line on our symbol. So now this one makes this direction. If you put a line on it, it makes a P for up. So you put your pencil in any point and you go straight up. And then you color, 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 color. And that is the solution to this inequality. So then it says write a possible solution, means write the actual answer. A solution is any ordered pair that lives in the colored area. For example, 3, 1 lives in the shaded area. So if you ever have ordered pairs with an inequality, you could just graph all of the ordered pairs and figure out which one is on the different side of all of the others. Or you could shade it like we did here, and you could see which one lives in the shaded area. Not too difficult. So that's how we graph inequalities. If there's no line underneath this symbol, make sure there's no line on my actual sign. It's a dashed line. If there is a line on the symbol, make sure you have a solid line that goes through your ordered pairs. Very easy. Next, we move into systems of equations. It's been a little while since we've done systems. What happens is when we have two equations, there's different things that could happen. So let's first take some notes on what could happen in a system of equations. So the first type, what happens here is you can graph a line, and then you can graph another line, and these lines cross at one spot. This is called one solution, and the ordered pair where they cross is the solution. The next example is if you were to graph a line, and then you were to graph another line, and they were perfectly parallel. Parallel means they look like railroad tracks. They're not bent towards each other at all. They have to be perfectly parallel. If they're perfectly parallel, they are never, ever, ever going to cross. So this one has no solution to this system of equations. The last type that could happen, but is not ever tested, you could draw a line, and then when you draw the second line, if it's right on top of the first line, we call that infinitely many solutions, or IMS. So hopefully you remember how to do these. So system of equations, they're either going to cross once, they're going to be perfectly parallel, which makes them no solution, or you would graph them and they'd turn into the same line, which is called infinitely many solutions. So with Desmos, for us to be able to figure out where two lines cross, the first thing we need to do is solve for y. So in my first equation, I'm going to rewrite this as 1x minus 1y equals 11. So now in order to solve for y, I need to start by moving my x to the other side. So I'm going to subtract 1x and subtract 1x. That leaves me with a negative 1y equals negative 1x and a positive 11. To get y by itself, I divide everything by that negative 1. So that leaves me with y equals negative 1 divided by negative 1 is positive 1x. 11 divided by negative 1 is a negative 11. So my first one is now ready to graph in Desmos. So now I'm going to take my second one, 2x plus y equals 19. To get y by itself, you start by moving the x to the other side. Hopefully you guys remember this. So that leaves me with a y equals a negative 2x and a positive 19. So now that one is ready to graph in Desmos. So I'm going to plug both of these equations into the calculator and see where they cross. So this is y equals 1x minus 11. And this is y equals negative 2x plus 19. Okay, I see where they cross, and I touch the ordered pair where they intersect. So these two lines cross right here. So I want to know where they cross. So they cross at 10. The blue line touches the red line at 10 comma negative 1. So that's the solution where these two lines cross. However, we have to be careful because it wants the x value. The x value is the number that comes first. So the correct answer is the x value of this solution is 10. Okay, you can try the next one if you want to. Solve both of those equations for y, plug it into Desmos, and see where they cross. The last type of systems are systems word problems, which are very easy. Hopefully you guys remember this. So what this says is we have 2 pairs of gloves and 4 hats, which cost $43. Then there's 2 pairs of gloves and 2 hats, which cost $30. So sometimes in the STAAR test, all they want is the equations. So your multiple choice answers might just be 2 different equations. But if they actually want the answer, if they want you to solve it, you have to switch it to x and y. 2x plus 4y equals 43. And then solve that for y. And then a 2x plus 2y equals 30. And then solve that for y. Solve for y, plug it into Desmos, and see where they cross. So the last piece of today is the unit you guys just did. So this should be super easy because we literally just did it. So it's really important in a parabola, which is a U-shaped, U-figured shape, we need to know what our things are. We need to know where things touch. So in this one here, my U shape touches the y-axis, so that's called the y-intercept. It touches the y-axis at 0, 3, so I put a 3 in the y spot of this ordered pair. At this spot and this spot, it's where my U-shaped graph touches the x-axis. So those are called x-intercepts. X-intercepts are also called solutions, zeros, and roots. So anytime you see those words, my answer is where it touches the x. It touches it at -1, and it touches the x at -3. Very easy. The ordered pair at the very bottom of a graph is called a vertex. To get to this vertex, it moved to the left 2 and then down 1. This vertex is at the bottom of the graph, so this is called a minimum. A minimum, the lowest number on the graph, is the number -1. So it's minimum because that points on the bottom. Then the last thing that's on the graph is an invisible line that goes right through the middle. That invisible line is called the axis of symmetry. I always make the x big because when you write it, you're always going to write it as x equals because it's an invisible line that crosses through the x-axis. Axis of symmetry means it's the middle of this graph. The middle of this graph is at the number -2. So the axis of symmetry is going to be x equals -2. Not too bad. Okay, next 3 are solving. Every single time you see an x squared and an equal sign, you have to look at the graph and find the x's. Step 1, it must equal 0. So number 1 is ready to go. It says, what are the roots of this graph? That means, what are the x's of this graph? So I'm going to plug it in. X squared plus 7x plus 6. X squared plus 7x plus 6. And you just touch them. There's one root here, and there's one root here. The correct answer is -1 and -6. Easy. Number 2, what are the solutions? Again, solutions are the x's of this graph. I want to know where this graph touches the x-axis. But there's an issue here. It has to equal 0. This one does not equal 0, so I take the number from the back and I move it over. The x squared and the 6x were fine, but I had to subtract 16 to move it over. So now I can type that in, x squared plus 6x minus 16. And then I touch where they cross, -8 and +2. So my answer is x equals negative 8. What? Negative 8 and x equals positive 2. Those are my solutions. That's where my graph touches the x-axis. Okay, try that one more time. The zeros are the same thing. If this one says f of x equals, you can just type it in just like that. Try number 3. Where does this graph? Where does it touch the x-axis? X equals and x equals. Not too bad. Okay, we also talked about moving quadratics. It's called transformations. So in this, you could always use Desmos and type it in. So from the original f of x equals x squared, that was the parent function. So the first one, a number in the back moves it up 4. This plus 4 is hanging out in the back. So a back number is a y number, like the y-intercept is in the back. So it moves up the y-axis 4. If the number is inside with the x-axis runs left and right. So it's going to be either left or right. But it's always the opposite of the sign. So you would think that a minus sign moves to the left. But the x is always a liar, so it actually moves to the right. So this one is right 2. You can always plug it into Desmos and see which way it moves. The next one, minus 6, another number in the back. If it's in the back and a minus sign, it means down. So this is going to move down 6. This next one is in parentheses with the x, so it's a left-right shift. The opposite of its sign would mean it goes left 3. The next one, a number in the front, is called a stretch. What that means is it gets narrower. It ran 4 miles, so now it's a narrower graph. The last one, every time you have a negative, what a negative does is it's going to flip your graph. It's going to be like this now, but we use the word reflect. Flip or reflect. So this last tab is the last piece of Algebra 1 that you guys have not learned yet, but I'm going to show you how to do it now, and then that's everything that we have. So the last type of graph we're going to learn is called an exponential function. There's this word called asymptote, which I'm sure all of you are like, what in the world is that? So how we have an asymptote, what that means is it's a wall. So this graph is never going to pass this line right here. That line, that barrier, that wall is called an asymptote. So this asymptote has a y in it. It's always y equals. This wall is sitting at the number 0. So my asymptote is y equals 0. It's almost always y equals 0. It just means it's a wall that this graph cannot cross below. Okay, last one. So in this here, we have a number in the front and then a number inside. A number in the front is called the starting number. So my starting number is 3. That's the initial value or where it starts. This number is smaller than 1. So if it's smaller than 1, it's called a decay. So this graph is going to decrease. It starts at 3, and then it decreases. It decays. Okay? The next one here, initial value is your starting number. So in this one, my starting number is a 6. The number inside is above 1. This one is more than 1. So this one is a growth, and it's growing 1.2. Okay? So it's a lot, but this is everything that you need to know. So we started off by talking about linear stuff, matching graphs or matching tables. Then we talked about slope, rate of change, systems of equations, quadratic functions, and exponential functions. This is all of Algebra 1 in a nutshell. If you ever see the phrase equivalent to, they use it all the time on this test. Equivalent to means you could type it into Desmos, type in your answer choices, and see what matches. But remember, with Desmos, it only works with the letter X. So just make sure, like in this example, if they give you the letter N, don't use N, just plug it in with an X. Okay? Good luck tomorrow. Do well, and that is everything for today. Make sure, last piece, make sure you bring a charged Chromebook. You can only use Desmos if you have your own charged Chromebook. If you never received a Chromebook, we'll have one for you. But if we checked out a Chromebook for you, make sure you bring it and it's charged so that way we can make sure that you can use Desmos on this test.